Hello student, today we are going to solve the questions of chapter number 2nd. It is the force and law of motion. In the previous volume we solved half of the questions, and in this video, volume number 2nd, we solve another half or remaining questions. So let's start. Watch the questions carefully. Question first is given here. Question number 6. A hockey ball of mass 200 gram traveling at a speed of 10 meter per second is stuck by a hockey stick so as to return its along original path with the velocity of 5 meter per second. Calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. In this question, the mass of ball is given 200 grams. It converts into kilogram. We divide by 1000 and it will be 0.2 kilogram. Initial velocity of the ball is 10 meter per second. U is equal to 10 meter per second. It is struck by a hockey. When the ball is struck to the hockey, it goes in the opposite direction. So with the velocity of 5 meter per second, so V is equal to minus 5 meter per second, because when the ball goes in the is this direction, its velocity is 10 meter per second. What it strike the hockey and goes in the opposite direction, so we take the velocity negatively. It is given 5 meter per second. Negative sign indicates the direction of the velocity. What is the force applied by the hockey? Change in momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Okay. We have to find the change in momentum. So we write here change the momentum momentum is equal to initial momentum minus final momentum. Initial momentum minus final momentum. Initial momentum is mu minus final momentum is mv. Mass is same, that is 0.2, and we can take common the mass. What we solve generally, mass is 0.2, initial velocity is 10 meter per second, minus mass is 0.2 kilogram, and final velocity is minus 5 meter per second. We solve it. 10 to the 20, 2.0, plus, because minus into minus will be plus, 5 to the 10, 1.0. We add this, 2 plus 1, 3, or 3.0 kilogram meter per second. It is the solution of this question. Next question, question number 7. we have to solve in question number 7. Given a bullet of mass 10 gram travels horizontal with the velocity of 150 meter per second. In the second question, in question number 7, a bullet, its mass is given, consider it is a bullet, mass is given 10 gram and velocity is a, initial velocity is given 150 meter per second. Strike a stationary wooden block. It goes in this direction and strike a stationary wooden block. It is a block that is made up of wood, or it is stable in rest position because its velocity is not, because it is in rest position, so velocity of this block is 0. We consider uh, v is equal to 0. So we consider it v1 and v2 is equal to 0. So we write here the given values. Mass of ball is 150, sorry, 10 gram. We convert it in kilogram. 10 upon 1000 is equal to 0.01 kilogram. Velocity of bullet v1 is equal to 150 gram and v2 and time taken. Time is given t equal to 0.03 seconds. When the bullet strikes this block, its velocity will be 0 in 3 seconds. Time is given t is equal to 0.03 seconds. In 3 seconds, it comes to rest. Block into the block. Also calculate the distance of the penetration of the block. We have to find the distance which the bullet travel in this block. What is the distance which the bullet travel after striking this block? So from the equation of motion, s equal to, because t is given, v is given, and so we consider it on u, and its final velocity is v is equal to 0. So from the first equation of motion, it is u and v is given 0. From the uh, second equation of motion, time is given, acceleration not given, acceleration is not given. Okay. Equal to u plus acceleration. From the first equation of motion, v equal to u plus at. Final velocity v is equal to 0 equal. Initial velocity u is equal to 150 meter per second and acceleration is not given here, so we have to find a. T is given 0.03. We solve it. We take 150 another side, so it will be a equal to 150. It will be negative upon 0.03. We remove this decimal from here and it will be minus 15, 1, 2, 2 zeros upon 3. 3 5 is 15 is equal to minus 500 meter per second square. The acceleration. It is the negative acceleration in which the bullet stops in this block. So A is equal to minus 5000 meter per second square. What we have to find the distance travel in the block, that is penetration. From the second equation of motion or third equation of motion, we can find out the given this value. Though we solve first from the second equation motion, that is s equal to ut plus half gt or at square. This putting the value u is 150, t time is given 0.03 plus half. A is we have to find A is find out minus 5000 and t is 0.03 into 0.03. We calculate it. From this 0 we remove decimal from here and it will be here. 15 3 is 45, because decimal is one place, so we put a decimal here, plus 1 by 2 of it will be negative 3 3 is 9 minus 5000 into 0 point. Decimal is from 1 2 3 4. 3 3 is 9. 0 0 0 9. We multiply 3 3 is 9. What decimal is 2 places here and 2 places here, so it will be on the 4 places. 1 2 3 4. We remove decimal from here and cut 3 zeros. From 3 zeros it will be here. So 4.5 plus 1 by 2 minus 5. 5 9 is 45. 5 9 is 45. 4.5. When we solve it, 4.5 plus into minus will be minus 1. We multiply 4.5 by 1, 4.5 upon 2. We solve it. We multiply 4.5 into 2, so 9.0 minus 4.5 upon 2. We subtract 4.5 from 9.0, it will be 4.5 upon 2. 2 2 is a 4, 2 2 is a 4, 2 5 is a 10 meter. Then the distance traveled by the bullet in the block is 2.25 meter. It is our solution. What in the another type we can solve this question from the third equation of motion. If we put the given value in the third equation of motion, we also find out the result of this question. From third equation of motion, it is v square equal to u square plus 2a. We put the value, final velocity is 0 is equal to 0 square plus initial velocity 150 square plus 2a is minus 5000 into we have to find s. 0 equal to square of 15 is 225 divided 2 zeros plus it will be negative minus 5 to the 10,000 s. So we put this value another side of equal, so it will be minus 10,000 equal to 2 to negative 225 into s. It is s. So it is s equal to, we cut negative to negative sign, s equal to 22500 upon cut 2 zeros and we apply decimal. From when we divide 225 by 100, it will be, we again cut this zeros 1 2, the decimal will be 2 places ahead, 1 2 here. So simply we solve this question this type meter. So you can apply the formula from, you can solve this question from third equation of motion or also with the second equation of motion. Choose what you will understand better and apply rest formula. But in the another part, it is it found have to find out the calculate the magnitude of the force exerted by the wooden block. We have to force on the block. So from the second law of motion, we know that F equal to mass into acceleration, F equal to ma. We put the values. Mass is given 0. Mass is given 0.01 and acceleration is minus 5000. We remove decimal from here, 1 2 places and cut 2 zeros. 50 1 the 50 minus 50 Newton. The block applies the force of 50 Newton in the opposite direction. Because minus sign indicate it, the force applied by the block is in the opposite direction of the bullet. Hence, the force applied in the opposite direction of the blade is equal to 50 Newton. In this way, we solve question number 6 and question number 7. Next question number 8. We are going to solve the question number 8 is saying that question number 8 is states that an object of mass 1 kilogram travel in a straight line with the velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. Then they both move together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. So we write the given value here. It is solution of question number 8. An object of mass 1 kilogram. M1 is equal to given 1 kilogram. In a straight line with the velocity of 10 meter per second. Its velocity is given here. V1 is equal to 10 meter per second. Collides with and sticks to a stationary wooden block. Mass of wooden block MT equal to 5 kg. Because in it is a stationary object, yeah, a stationary block, so it is in the resting position, so Vt is equal to 0. They both move off together in the same stream, but we have to calculate the momentum just before the impact. So momentum of the momentum before collision. M1 V1 plus M2 V2. It will be mass of block, mass of object is 1 kilogram into velocity is 10 plus mass of block is 5 kilogram and velocity of block is 0. So 10 means 10 plus 500 is equal to 10 meter. 10 kilogram meter per second. It is the result of the in momentum before collision or the uh, total momentum just before the impact. And just after the impact also calculate the velocity of the combined object. Second, we note that the momentum of any block is just before and just after the block is same on the basis of conservation of momentum. Law of conservation of the momentum. Conservation of the momentum states that the total momentum before collision, before impact, is equal to total momentum after impact. impact. Conservation of momentum is stated that the total momentum before impact is equal to total momentum after impact. Momentum is conserved, so total momentum before impact is equal to total momentum after impact. So it is the second result of this question. After the impact is also it will be 10 kilogram meter per second after the impact. The total momentum after impact will also be after impact equal to 10 meter 10 kilogram meter per second. It remains the same. But we have also calculate velocity of the combined object. We consider the velocity of combined object VB. The velocity of combined object be V meter per second. We solve this. In this conclusion, we put the value m1 v1 plus m2 v2 is equal to m1 plus m1 m2 into v2, because we consider the combined velocity of the object is v. After collision, both the object and block comes together and they both goes in the same direction with the velocity of v. In this way we found out that it is 0 and its velocity is 10. Momentum is 10. It is 0 is equal to m1 is 1 and m2 is 5, and we have to find 10 is equal to 5 plus 1 6v. We have to find v is equal to 10 by 6, 2 5 are 10, 2 3 are 6. V is equal to 5 upon 3 meter per second. It is the velocity of combined object. In this way we solve this question number 8. Another question number 9, we going to solve. Question number 9 is saying that an object of mass 100 kg is accelerated uniformly from velocity of 5 meter per second to 8 meter per second in a 6 seconds. We write the given values here. M1 M is mass of object is 100 kg. Its initial velocity is 5 meter per second, and final velocity v is equal to 8 meter per second in 6 seconds. Time is given is equal to 6 seconds. Calculate the initial and final momentum of the object. Initial momentum of object is equal to mv1 mu, sorry, mu. Your initial velocity is u, then into 5 is equal to 500 kilogram meter per second. Number 1. Calculate the initial and final moment of object. Okay. Final momentum of object m into v. M is 100 and velocity v is 8 kilogram meter per second. Also find the magnitude of the force exerted on the object. We have to find, it is answer number first, it is second, and we have to calculate the magnitude of force exerted on the object. So from the second law of motion, we know that F equal to m, where m is mass of the object and a is acceleration. Another, we know that a is equal to the change of rate of momentum is acceleration. Another way, from the first equation of motion, we know that v equal to u plus at. From here, at to v, take u from here, another side, it will be negative, is equal to at. We take t here, to v minus u upon t is equal to a. A is equal to v minus u upon t. We write on the place of acceleration v minus u upon t, or a equal to v minus u upon t. So F equal to mass into v minus u upon t. Putting the values, it is 100 kilogram and v is given 8 and u is 5 upon t. Time is given, time is 6 seconds. 500 into 8 minus 5, 3 upon 6. 3 1 is 3, 3 2 is 6. Big 2 5 is 10, 0. So force 50 Newton. Also for the momentum 5 meter 2. Okay, because here the velocity is increased, so to increase the velocity we have to apply the force of 50 Newton along the direction of the velocity. In this way we solve the question number 9, and last question of this exercise or this chapter is given. This is very easy questions. Uh, how much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeter? It is a dumbbell, a block. It is dropped in from a height of 80 centimeter. So height is given h equal to 80 centimeter or 0.8 meter. H equal to 0.80 centimeter or 80 upon 100 is equal to 0.8 meter. Transfer to the floor if it falls from a height of 80 centimeter, and it is work in under gravity. So we take the gravitational acceleration g is equal to 10 meter per second square. Height is given and mass of object is also given. It is 10 kilogram. For the momentum, we know that the velocity, here initial velocity is 0 and final velocity we have to find. Then we calculate the momentum of the dumbbell of mass. Initially we have to solve value of v. In this equation we can see that h is given, height is given, mass is given, g is also given, but time is not given, so we cannot use the second equation of motion and first equation of motion. We can use only third equation of motion. In the it is along the under gravity, so we write here a third equation of motion. It is v square is equal to u square plus 2gh. Under gravity, we put g. It is the gravitational acceleration of the earth on and its value is 10 meter per second square. We put the values. Initial velocity is 0 and final velocity we have to find. V square is equal to u square, u is a 0 plus 2, g is 10, h is also given 0.8. So 0 plus 2, we cut 0 from and remove the decimal from here. 8 1 8 2 16 is equal to 16 plus 0 is equal to 16. V is equal to root under 16, square of 16, square root of 16 is 4. Because 4 into 4 is 216. From the pair, we V is equal to 4 meter per second. Sorry, per second. What we have to find the momentum? We know that momentum P equal to mb, and mass is given 10 kilogram and velocity is v4, that is 10 for the 40 kilogram meter per second. In this we solve all the questions of this chapter. You have any problem, you can write it in the comment box. So in the next videos of the next chapter we met again, and thank you for watching the videos.